Hi, Doc. Thank you so much for coming on to the Stop Chasing Pain podcast. It really, truly is an honor to have you on my show today.
It's a great pleasure to be with you, Perry. I'm delighted.
Well,
Yeah.
I'll be honest with you, Doc. I'd probably want to keep you here for several days, but I know I've only got you for about an hour, and want to talk about something that you really got me turned on to, um, and that's water. Your book, The Fourth Phase of Water. Got to say, one of the most transformational books that I've read that really got me to think, where I would read a couple of pages, put it down, and just think about what I just read because it just blew my brain cells up a little bit. So let's start with
You're very
what
kind.
got you
Thank
wanting to
you.
look at water.
Yep. What? I'm sorry. Could you repeat? I think we were talking over one
Oh, no
another.
worries, no worries at
Yep.
all. So what was it that attracted you to start to work in the realm of dedicating your life to looking at water?
Yeah. Okay. So my previous life at the University of Washington was studying the molecular mechanism of muscle contraction. I spent a lot of time on that subject, and I think we made some gains. And in the interim, I happened to meet a guy who was studying water in the cell, and his name he passed recently, um, not quite achieving 100 and years old. His name is Gilbert Ling, and Gilbert was Gilbert was a scholar coming from China. He was one of three to come after World War II. The Chinese decided that they're going to pick their best scholars and come to study in the US. And he was one of three. And he didn't win a Nobel Prize, but one of the cohort won a Nobel Prize in physics. And they all thought Gilbert was maybe the smartest of the three. Uh, so Gilbert, in studying the water inside the cell, he came to a conclusion that differed radically from the, the way people generally visualize the water that's inside the cell. You know, the cell is mostly water, 2/3 water, but um, most scientists have a sense that that water is no different from the water that's sitting inside this cup, liquid water. Um,
Mhm.
but Gilbert said, no, that's not the case. He said, if you look at the evidence that is that the water inside the cell is structured. He used the term structured. And what he meant was ordered. It means the molecules were kind of lined up in some way, the water molecules. And the lining up of water molecules, of course, suggested uh, various mechanisms inside the cell that would differ radically from what mainstream biologists were thinking at the time. I happened, it happened to be good fortune that I met him at a conference in Budapest, and I was totally blown away. I'd heard about him before, and it was not my field. It was a conference to commemorate the work of a famous biophysicist who had passed. And there were two contingents there. One is the muscle contingent, and that was me, because this guy had a radical view, maybe similar to mine. And then the other interest was water. And the chief protagonist, shall we say, um, whom that biophysicist followed, was Gilbert Ling. And so it was not just Gilbert, but a dozen or so of various colleagues from around the world who had evidence to support his point of view. Well, I was transformed by that. I really was. And I came back and I gave one of his books. By that time, he'd written, I think, 4 or 5. The books are not so easy to digest, I must say. I gave it to uh, my students and postdocs in the lab, and every one of them came back to me and said, you know, this guy is on to something really important. And if he's right, this is going to transform all of biology. So I'm thinking, what should I do? I'm an activist. I decided to write a book. And it was in 2001 that, not the book you were mentioning, but it's called Cells, Gels, and the Engines of Life. I don't know if you're familiar with it or
I
not, but
actually have it. I've
oh, you
read
have
that.
it.
I've got
Okay.
highlights in it.
Oh, wow. Thank you. Okay. It's got a pretty cover, and the book was controversial, um, but the intent of that book was to present the ideas of Gilbert Ling in a way that was palatable and understandable to people like myself, maybe you and others who didn't have a vast background in physical chemistry, and even if they did, they struggled to understand what Gilbert was trying to say. So I did it, but I went beyond what Gilbert Ling was espousing, and Gilbert was not very happy with the fact that I went beyond what he had to say. And what I suggested in the book, not only that Gilbert Ling's ideas seemed to be well-founded, um, but but also that I could go one step further. And that step was to suggest that that ordered or structured water, um, that 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 each cell was full of it, and that when the cell moved to action, for example, when a muscle cell began to contract, or when a nerve cell began to conduct, um, the trigger was actually a destructuring of that water. In other words, the water is turning from the ordered, structured water to ordinary water. And with that transition, the proteins in the cell, uh, which are responsible for the cell's activities, also underwent a transition. So when the cell was stimulated to do its job, everything changed. It was a so-called phase transition that occurred inside the cell. Both the proteins doing the work and the water changed. And then when the cell was finished contracting or doing whatever, it would return to its initial condition. So it meant that the activity of the cell depended entirely on the water. The water is absolutely critical. The water undergoing a transition from its quiescent state of order uh, to its active state of disorder. And that disorder, the water was pretty much like the water in this cup. So I think Gilbert was not very happy about that, but it inspired me. And we changed radically. We've been, as I said, studying muscles, and I think making a lot of progress. People didn't necessarily like our contributions because they challenged a famous Nobel laureate who was
Mm.
like a godlike figure in science, Sir Andrew Huxley. And his theory prevails to this day. And our ideas, our evidence, or rather theory and mostly evidence, is mainly ignored by the establishment. But anyway, it was a transition for us to begin studying water because I knew it was so important. Does that answer your question, or is there?
Yeah, that's great. So I'm curious today, we were talking a little bit before we started to record. I mean, with since the first phase of water that's come out, and that was 2013, looks like the published, and now it's 2020, has the establishment per se started to grasp this work, or they're still not accepting of it?
No, they're mostly not accepting it. There are two, well, mostly, not all. Um, there are two factions. Uh, Almost, there are a few laboratories that have done experiments, and they claim that that refutes um, the theory of a fourth phase of water that is beyond solid, liquid, and vapor. I don't agree with what they've done, but the vast majority of people are just simply ignoring it. And some people have said, even to me, they're waiting for others in the scientific mainstream to accept it, and then they'll take it seriously. But that hasn't happened. And there's a conference, for example, on water. It's a so-called Gordon Conference. I'm not sure if you know about it. Scientific conferences on so many different topics, and there's one on water.
I
It
didn't know that.
occurs.
No.
Well, it occurs, and it's mostly people doing simulations, computer simulations of, for example, how water molecules, how 1,000 water molecules would behave in the presence of some interface or solid nearby. And they go through and they present it at this conference, and they don't take into account the possibility that something else might be going on, like this fourth phase. And And by my spies who attend that meeting say that our work is essentially completely ignored. If it were taken into account, essentially everything that they are doing would be, I hate to say the word wrong, but I think it would be displaced by newer information. So yeah, so you're, in response to your question, most of the mainstream people have more or less pretended that this doesn't exist. Now, it's not true of people outside the water mainstream, because water is so incredibly important for so much of nature and technology. And there, the response has been overwhelming. I, I like to point out reviews and such, and if anybody looks at the reviews on Amazon, for example, I think they'll get the picture right away. Um, the reviews have been just incredible. I sometimes I have to pinch myself to see. So anyway, that's my evaluation of the status right
Yeah.
now.
Well, I mean, that's hard for them, any kind of thing to get a reframe, right? When you're challenging some paradigm that they have. And I got to tell you that I recommend the book to everybody. And then whenever I speak to someone who's read it, or I recommended it to, they always say the same thing. That it's one of their favorite books of changing their perspective on how to look at the body, which yeah, it leads me to my next question.
Okay.
So, if we know that the water is so critical to human health and physiology and cellular function, um, what happens if somebody doesn't have that? Is it that they don't have the structured water, or they need to get the structured water, or the body's just lost the ability to structure, and then that leads to them getting these uh, maybe autoimmune, chronic illnesses, inflammation, and stuff that they have? Is there a correlation with that?
I think so. We've never studied inflammation directly, but one of the things that we've established is that as I started to talk about, and we've actually gone a long way beyond Gilbert Ling, but one of the things that is critically important is uh, the cell must have its full complement of, we call it fourth phase water, or EZ for exclusion zone, easy to remember. And I'll refer to it either way, the two are pretty much the same. It's an ordered form of water, but different from, I think, what Gilbert Ling had suggested. And I can go into the differences if you like,
Yeah.
well, okay, but I want to get back to your question. But
Yeah.
let me just describe the some features of the water that I think is what the so-called structured water really is, based on the experiments we've done. It's not just molecules lined up; it's actually a change. So the water molecules are broken up into a negative part, that's OH minus, and a positive part, that's H plus. And the OH minuses line up to form a kind of coherent structure. Excuse me. And they do that next to a surface. So if you take a container of water and you put in some material, and a material that has a hydrophilic surface, that is a water-loving surface, a surface where if you drop water, it'll spread out. Most of those surfaces, not everyone, most of those surfaces then provoke this transformation of water into something that's a little bit different. And the difference is that those OH minuses aggregate together next to that surface to form what is like a honeycomb sheet of oxygens and hydrogens. And once the first sheet forms, then that forms the template for the second sheet and the third, and these sheets can build. And uh, and that's the water we're talking about, fourth phase water. It's not as Gilbert Ling suggested. Now, to build this water, you can't build order from chaos, or you can, but only if you have energy. And it turns out that the energy for going from chaos to order, the chaos being ordinary water, and the order being this fourth phase water, these sheets, stack of sheets, the energy comes from light. And I guess I hesitate to say that we discovered it. It was actually a student, an undergraduate student in the laboratory. And most of the most interesting findings come from these young, eager students. And the student was looking at a chamber in which we have an exclusion zone set up, or fourth phase water. And he took a lamp that was sitting right next to him, and there was a gooseneck lamp, and he shined the lamp on the chamber with the exclusion zone. And what he noticed was that the exclusion zone grew enormously. And then he called me in and he said, "Hey, look at this." And I thought, wow, this is really interesting. So I suggested take away the lamp. And sure enough, the expanded exclusion zone went back to the original size when he took the light away. So it didn't take a genius to figure out that that light photons were creating the energy for building this kind of water. And after that, of course, we did serious experiments, and we found that infrared light was the most powerful of all. I mean, vastly more powerful than visible light, for example. And so, you know, most people don't know much about infrared light, except it's associated with heat or something. And, you know, if you look at the toaster that's toasting the bread, if you look at the coils, they're glowing bright orange. And some people will say, oh yeah, that's giving off infrared light. But it's much more than that. It's not just your electrical oven or toaster. It's all over the place. And if you were to turn off all the lights in the room in which you're sitting, and take out your smartphone camera, I have none, by the way. I avoid cell phones. If you do that, you see nothing. But if you had a camera where the sensor was not a sensor of visible light, but a sensor of infrared light, then even though it's dark in your room and you can't see anything, the infrared sensor will pick up a beautiful image of you and your glasses, and the curtain that's sitting there, et cetera, et cetera. And that's why it's used as by the military to detect targets when it's nighttime. So that's the energy we're talking about. And you need that energy to transform the ordinary water into easy or fourth phase or structured water. And that's in the environment. It's all over the place. You can't get rid of it, or it's impractical or almost impossible to get rid of it. So because it's always around, it means you have easy water that always exists. If you have water, if you have the right kind of hydrophilic surface, the water will transform itself automatically in the presence of that light energy into fourth phase water. Okay, and the final thing, so that's the energy, that's it. The final thing I want to say, because it's needed depending on the questions that you're going to be asking, is that it's not neutral. H2O is neutral, but this stuff is charged. Typically, it's negatively charged. So that means that if you stick an electrode into easy water, typically you'll find a sizable negative electrical potential. And the water beyond that has positive charge. So if you remember, I said the water molecules break up into the negative OH, the positive H plus. And the positive H pluses are sitting in the water, the ordinary water, beyond the fourth phase water. So you have fourth phase with negative charge next to water with positive charge. It's a battery. And this battery provides energy for your body. So okay, so this is just background material, and all of this appears in the book that you mentioned, but I had to mention it because those are the principal features, and you need to know the principal features in order to look at the applications. And I think the application that you are mentioning is human health, and why do you need this fourth phase water and such, or correct me if that's
yeah, I find so many people that I come in contact with are in a state of dehydration, even though they're drinking a lot of water.
Yeah. Okay. So So that's a really good point. And as you know, if you're thirsty, or even if you're not thirsty, if you drink water, I drink a fair amount of it, some of the water gets peed out. Um, and other of the water gets transformed by this kind of energy that I was talking about, gets transformed into fourth phase water. And where does the energy come from? Well, it comes partly from outside. As I said, there's lots of infrared energy to do the job. But inside your body, you have all these metabolic reactions going on. They produce heat, infrared energy, and that infrared energy is used by all the cells in your body to build easy water. So with each swallow of water, some of that water is being transformed into fourth phase water, which essentially is hydration. That is hydration. So if your cells are well hydrated, it means they're full of easy water. And some waters can do better than others. We've just begun in our laboratory testing various kinds of waters to see which ones are best for hydration. We submitted a manuscript, and we only studied a handful. So I would hesitate at the moment to say anything beyond that. Some waters are better than other waters in terms of building hydration. But it's not just drinking the water that gets transformed by your body and my body into easy water, which makes cells function properly. But you can also drink easy water, and the way you can do that is a simple expedient that I'm sure, know about is by juicing. So what is it about juicing that can give you fourth phase water? Well, what you're doing when you juice is you're taking the greens from the plants, fresh, new, robust green leaves, and basically squeezing out the water. So the water is the water from inside the plant, mostly from inside the plant cells. And just like you have easy fourth phase water inside your cells, so do the plants. So what you're doing is squeezing out easy water. And if you drink that water, you're directly imbibing easy water. And so the body doesn't need to go through the process of transforming ordinary water into easy water. You've got it already. And so that's another way toward health. And I know that many health practitioners who I've spoken to tell me a patient, not mainstream, but non-mainstream, will tell people to do juicing. It almost doesn't matter what their affliction is, just drink the juice from the plants. And I'm told by these people, they come back a few months later that they're feeling much better. Doesn't matter what the problem is, they feel better, and they've also lost weight for reasons that are less clear to me. But I think what they're doing is they're supplying easy water to the body. It seeps into the cells. The cells need this easy water to function, and therefore people function better. So maybe I better stop, because I feel like I'm going on with a lecture rather than answering questions in an interview. So please go on. There's much more to say, but I hear the questions from you.
Oh, no. I mean, I could just sit back and let you take you just keep going. I mean, I'm just sitting here mesmerized. So,
well, you may think so, but your listeners might not. Yours, they may get tired of my voice.
Well, I want to get back to the light part, because I was reading about that with, light and the water in the body. So is it a matter of sunlight being a big factor in that for people?
Yes. So in Seattle, where I live, in the wintertime, we don't see the sun too often. It's pretty cloudy and I would say gloomy. And when the sun does come out, it does occasionally, people feel happy. And the happiness, the thought is, well, it must be purely psychological. You see the sun and you're really happy to see all that bright light. But I think it may be something beyond just that. This sunlight that's coming, sunlight consists of visible light is what we see, but also warmth. And the warmth comes from the infrared that's coming from the sun. And my student taught me something that I hadn't realized, that more than half of the sunlight is in the infrared. So this sunlight, if it comes out suddenly and bestows its rays on you, what it's doing is providing infrared energy. And that infrared energy is absorbed by you, certain wavelengths more than others, and it's absorbed by your entire body, even through some of your clothing. But you feel it, and so the effect should be, I think. I would say, I would conjecture that what the sun is doing is providing infrared, builds easy water, and your cells, the ones that are deficient in easy water, maybe creating the depression that you're feeling from all of those clouds, will vanish because your brain is now functioning in a way that it's designed to function. And it's not designed to function with gray skies. So I think that's the answer regarding the sunlight. But I need to take one more step, because there's another way of getting this kind of energy that people do. I don't do it very often, but the people in, and that's the sauna. And the people in Scandinavia do it all the time, and the Russians do it. They call it banya instead of sauna. And many people have a really positive experience. I have myself. I remember an experience in Finland. I was at a conference, and at the end of the conference, they took us to some remote place for a party, and it was getting to be 10 or 11. I was really, really tired. And one guy came to the microphone to make an announcement. I was sure he's going to say, "The bus is ready to take you back to your hotel." Instead, he said, "Okay, the sauna, excuse me, they pronounce it correctly. The sauna is now open." And I was so disappointed, because all I wanted was to go to sleep. I was so tired and jet lagged. Okay, so I decided, everybody's trying it, I'll try it. So I tried it. And it had 3 different types. One was a humid one was dry, but they were all the same. Essentially, they provide heat, right? And so what's heat? Well, heat is infrared. So you're sitting in this room getting bombarded with infrared energy. That heat is infrared. And especially without clothing, your entire body is absorbing it. And I got to tell you what a powerful experience that was for me. I had similar experience in Russia, but this one was remarkable. After 20 minutes and then a shower, and I went back to the room where all of us had been gathered, and I felt like it was morning, like I'd had 8 hours of sleep. It's the next day. I feel totally refreshed. I can't remember that I had pains or anything, but in terms of my mental being, it was amazing. So what is it? Why do people report that everything feels better after the sauna? I think it's the infrared energy that's being absorbed and building easy water in all of your cells, or whatever cells don't have a full complement, and allowing those cells to behave the way they were, shall we say, designed to behave. So yes, sunlight, and I extended that to really powerful sunlight, and that is the sauna.
Yeah, I love that. Well, as soon as I read that about light, I got really excited, because I've been doing different types of light therapy for, I think, 12 years now,
Oh, okay.
from, visible red light to near infrared, far infrared, and then laser therapy for people. And I recently got it's called a Theralite 360. It's a full bed that you lie in, and you pull the top down like a cocoon, like a tanning bed.
Oh, yeah.
And it's all the different wavelengths of the light, from the near
Yeah.
infrared, far infrared. And I'm in that thing for 20 minutes. And I got out of that thing, and I feel like I just turbocharged the whole cells in my body. I love that
Wow,
thing.
that's powerful. That's amazing. Right.
Yeah.
totally.
And then now I see it equated with the water. You know, it's just
Well, I mean, yeah, it's I think based on the evidence that we've obtained that it's happening in the water. There are other theories around many of them as to
yeah,
why light therapy works, but it really seems to work. I remember one powerful experience. It was in Germany or Scandinavia. I forget. Someone came to me after a talk, and he said he was a physician, and he specializes in well in cancer. And so some young women had come to him, and some kind of tumors were spreading all over their face, and their alternative was surgery. And you know, no woman or man particularly appreciates massacring their face. So he began using infrared light. He said it was like magic. It just absolutely wiped out the problems that these women were having. And I remember it because it made total sense for me. And he actually agreed that it could well be something to do with the water that is being treated. You know,
yeah,
can't, yeah.
I think so. And I mean, I've started to research that a lot more for myself, and I know that people have been telling me like, "What have you been doing? You actually look younger." And I'm like, "Okay, well, I love to hear that, but let's."
Well, it depends on your age. If you're 14, you may like to look older.
Exactly. So let me ask you a question. What about seawater? Does that have anything correlation to the waters that are is in our body?
Well, yeah, I mean, there's um, um, you know, it's full of salt, as everybody knows, and your body is also uh, filled with salt. But the I guess the one of the prime distinctions is that inside the cell, unlike the seawater is filled mostly with sodium chloride, um, and inside your cell, it's filled mostly with potassium. Um, Outside the cell is different. It's sodium, just like seawater. So many people have said, well, yeah, extracellular fluid is actually very much like seawater. And in fact, 100 years ago, um, now resurgence, there was a treatment of various diseases by injecting seawater into blood. Um, I forget the name of, you might know it, but it was used therapeutically, and then came antibiotics. And so it was really easy. Take an antibiotic, you know, inject it, and that's it. You didn't have to drink the seawater. This was special seawater that came from Europe, somewhere between France and Spain, um, uh, from various beds containing algae, if I remember correctly. And this was used routinely, and apparently it was really good for health. It's being revived now in a company in Spain. They're using it, but you know, there are limitations to it, because if you capture seawater to inject into the body, although it does have all of these apparent health benefits, there are restrictions, because you can't guarantee that each dose is going to be exactly the same as another, because it depends where you get the water.
Right.
So they've encountered some difficulties, but still, it's a quinton. It's actually pronounced quinton, Quinton, water, um, French name, I guess, and it's still being produced. So yes, the answer to your question is the body's water, especially outside the cell, is similar to seawater. And you know, maybe that's why this Quinton water is actually apparently really good for your health.
Yeah, yeah, I've heard of that. Yeah.
Okay, yeah, sure.
I got a question for you. I'm not sure if you will have an answer for it, but
Probably not.
within the last 3 to 5 years, because I got really sick on my own and from an autoimmune disease, and I was really sick, and I brought myself back through many, many different ways. And one of the things that I was looking at was hydration and water, and then the structured water. But I started to work a lot with a system that very few people talk about, which is the lymphatic system and its job in helping the interstitial fluid that surrounds the cells to be conducive to absorption. I wonder if you find any correlation between the interstitial fluid slash extracellular matrix and with the inner part of the cell and the lymphatics and absorption at all.
We haven't studied the lymphatics in any serious way, except if I tell you a little story.
Yeah.
Yeah. So one of the issues with lymphatics, and then I want to get back to the immune system
Yes.
you started with, because there is something to say about that,
Okay.
which is rather unconventional, but I think very important. Lymphatics. So one of the questions is, what creates flow in the lymphatics? And there are a few ideas that have been tossed around, but I think we've come up with a mechanism that is a real candidate to propel flow in our body, not just in the lymphatics, but mainly in the cardiovascular system, if I may. So it starts in the laboratory and it progresses to animal studies. In the laboratory, we found something peculiar. We put a tube like a straw made of hydrophilic material. We started using a tube made of so-called naphthion, which is a polymer that's hydrophilic, but it doesn't matter. We've seen the same with many tubes. You put the tube in the water, and the tube is like the straw lying horizontally. And a student, another undergraduate student, came running into my office without knocking. It's okay. I'm pretty easy about stuff. But I had an important visitor sitting next to me, and I guess I might have appreciated it if he knocked gently, but he came barging in because he was excited. And actually, secretly, I said, this is fine. He said, I saw something, and I had to come tell you. So, well, what is it? He said, I think it's important. This tube that's lying in the chamber, I see the water flowing through it, and it just keeps flowing without stopping. And he said, I thought, this is a pretty interesting observation. And I thought, well, this is an amazing observation, if true. And it turned out to be true. We checked in the laboratory, and several other people could repeat it. And I thought, excuse me, what this means is that something we found earlier, that the energy is supplied ultimately by light from the sun, infrared light, infrared energy. I thought this could be the ultimate proof, because there's nothing else to propel the flow. Usually you need a pressure right. Gradient. Yeah, like in your cardiovascular system. But, there's nothing to do it. And yet it looks like you're getting something for nothing, but that you can't get something for nothing. So we deduced that it had to be the light that was doing it. So then from the laboratory experiment that we could confirm, and we began to deduce the underlying mechanism in some detail. I had a trip to Russia, and in that trip to Russia, I was introduced to a guy in the laboratory next to my friend Vladimir from Moscow University. And the guy was telling me there's a big problem in the cardiovascular system. Not lymphatics yet, but he said, so I said, well, what's the problem? And I said it with my nose up in the air, because I began my scientific career as a graduate student studying flow in the cardiovascular system. And this guy is going to tell me there's a big problem in the cardiovascular system. I said, what are you talking about? So within 5 minutes, he had me convinced that I was wrong and he was right. And that happens often. So what is it about? He said there's a big problem because the capillaries are pretty small in healthy young adults, not me, healthy young adults. The capillaries go down to 3 or 4 micrometers in diameter. And that's 3 or 4 micrometers compared to 6 or 7 micrometers for the red blood cells that need to squeeze through, right? There's a engineering problem here. It's sort of like a, plumbing problem. It's like something getting stuck in your toilet, and you pull out the plunger and you got to push down to get it working again.
Yeah.
So you've had that experience. Most of us have. It requires energy. So this guy calculated how much energy was required, and it was enormous. He said, in order to squeeze the red blood cells down, and you can actually see them in videos, you can see as they pass through the capillaries, they're squeezed. They're like this. So you need energy to squeeze them to let them go through. And it kind of looks like Mother Nature has made an error, but there's method to her madness. Anyway, the energy required is so vast that he calculated that if the heart alone were responsible, the pressure that would need to be developed by the heart, pretty high, would be something like 1 million times the pressure that it develops. And you might call that high blood pressure, but he said it's impossible. And I'm thinking, well, this is pretty interesting. Even if he's off, as calculations can often be, by a few orders of magnitude, still, it's a big difference between what the ventricle can produce and what's needed. And so I guess I inspired one of my students to check to see if this is occurring in the cardiovascular system. In other words, the question is, in addition to the heart propelling flow, is there something else that propels the flow? Is this mechanism that we found in the laboratory, this so-called spontaneous flow, is it working in your cardiovascular system and mine? And the answer is, it looks that way. And the experiment was actually pretty straightforward. He first stopped the heart. This was in a chick embryo, 3-day-old. So it's a mammalian preparation. And he stops the heart, and the heart stops. And you'd think the flow should stop too, but the flow didn't stop. It went on. It was going at a lower velocity, but it just kept going. It's not supposed to happen because the heart's not beating. So we saw right away that there really is something else that's propelling the flow over and above the heart. And then we tried to check the key signature feature of this phenomenon, that if you add infrared energy, it goes faster. And we confirmed it in this mammalian heart preparation. So we conclude that it looks likely that in your heart and in my heart and in everyone's heart who's listening, it's not just the heart it's not just the heart that's pumping. It's also this self-propelled flow in the capillaries that is working in addition to your heart. You see, and I think this is really important because it has obvious therapeutic implications. But the reason I went into this in detail was the lymphatics, because nobody really knows for sure what's driving the flow in the lymphatics. We haven't been able to study it directly because it's not so easy to study, but I think it's very likely that the same mechanism that we've identified that's propelling flow in the capillaries is also doing the same in the lymphatics and perhaps also the veins. Sorry about the long.
I think you're probably right. Yeah, nature's pretty smart in how she designs things.
Absolutely smart.
We just haven't figured it out yet.
I don't know what other questions you have in mind, but
yeah, I wanted to cycle back to what you mentioned. I know we're getting close on time because you have to leave in about 5 minutes. What did you want to say about the immune system?
Okay, it may take a couple more minutes than 5, but it's okay. We're not quite there yet, but you may have to go. In the immune system, information is very important in the immune system, because immune to what? Well, immune to certain substances that carry information. And I just want to mention something that would seem controversial, extremely controversial to many, but I think it may be actually true because the evidence is there. And that is, can water store information? And before your listeners turn off at this heretical kind of idea, let me just say a few things. So I organize each year the annual conference on the physics, chemistry, and biology of water. This will be going into its 15th year. It attracts a lot of people, including Nobel laureates and younger people really seriously interested in experiments. And each year we have 3 or 4 speakers who talk about information in water. And each one comes with evidence for it. This is not just a kind of speculation. And then includes, one example is Luc Montagnier, who won the Nobel Prize for discovering HIV. He comes just about every year, and he presents evidence that water can store information, especially biological information. And this was long ago laughed off by mainstream science as being not only unlikely, but even stupid. This is crazy because, why? Because a glass of water, liquid water, the molecules are randomly oriented and bouncing around a gazillion times per second. How is it possible that water could store information? However, we now know that easy water is not like that. Easy water is a structure that is organized like a crystal, and crystals store information. That's exactly what your thumb drive does in your laptop. It's built of silicon crystal, and each atom of silicon has 2 different states, and we tend to call them 0 or 1 or on or off. And it's that array of different states that is able to store information. Well, the EZ water, as I've described its structure to you, it also is a 3D array, in this case of oxygens and hydrogens. And it turns out, the question is, well, do the hydrogens or oxygens have 2 different states? Turns out the oxygen has not 2 states, but 5 different states. The one we learn about is an oxidation state of -2, like a valence of -2. But if you look at any chemistry book, it'll tell you it has -1, 0, +1, +2 as well. So it means that, at least in theory, easy water has the capacity to store information. We haven't figured out exactly how to do it, but in theory, not only could it store information, but it can store information with an information density that would be something like, I forget, we calculated something like between 10 million and 1 billion times the density of information right now that exists in your laptop. So it's pretty exciting, and I wanted to suggest that because the information could be can come from a distance. It doesn't have to be right there. So when we think of, for example, viruses or such, or any kind of information, the information can actually come from some distance and still be incorporated into the water of our body. And that's not only what Professor Montagnier has found, coming year after year to present his results, but many other people in many different contexts. At our conference right now, this is kind of more or less accepted that water can store information and can also deliver information. So this is very exciting from my point of view, although, from someone coming to this from a distance, I'm sure it sounds preposterous.
Yeah, I mean, I think it's absolutely fascinating. Yeah, I love it. I mean, that sounds like a conference I would love to be able to get to.
Please come. It will be April 22 to 25, 2021
Where
in
at?
Germany.
In
Bad
Germany?
Soden, right not far from Frankfurt Airport, close enough to be convenient, 20-minute drive, but far enough so that you don't hear the drone of the planes coming up above. It's a charming town.
Well, you have me at water, and then you throw in Germany. Germany's one of my favorite places on the planet.
Oh, that's great. Yeah. Yeah. Well, you should
Do you have time for one more question?
Yeah, I have time for one more.
Okay.
My visitor is coming, hasn't quite appeared.
So I'm not sure if there's an answer or if it's a rabbit hole you want to go down, or if there's just not enough information about it. If we go back to water carrying information, what do you think about all the EMFs and what that does to the body, and will that influence water in our body?
We found that it does. and this is preliminary data. I want to stress that because I've not yet thoroughly examined the data produced by a student in the laboratory, but it looks promising. And what the student did was to take a chamber similar to the one I mentioned earlier, where we have an exclusion zone built up next to a hydrophilic surface. He took a router and placed the router near the chamber. And when he turned on the electromagnetic signal from the router, he was watching the EZ and it diminished. Not hugely, but it definitely diminished. And it looks as though the results are pretty consistent. So we're now putting it together, and I'm examining it. And if it turns out to be accurate, I think it is, but I just want to make sure I label it as preliminary before I've had a chance to do so. It looks as though a standard route, the radiation coming from a standard router, has a tendency to diminish EZ water, and if it does, it might have health impacts. But beyond that, there are a lot of people who are obtaining evidence for this, and it's not mainstream because sometimes the reports are removed from the mainstream, unfortunately. So we don't get all the information, but I've spoken to enough of these people because I come into contact with them that there is serious worry by many people, especially in your favorite country of Germany. They're well aware of it, and I've been to many conferences. They're dealing with health and environment, and boy, they're absolutely, to practically the last person either on the podium or in the audience, they know this is a real problem. And they're especially concerned with 5G. And if I have one recommendation, if there's anybody who would like to find out more in a comprehensive way about the influence of electricity in general, not just Wi-Fi energy, but electricity in general. There's a book by author Arthur Furstenberg called The Invisible Rainbow. I'm halfway through right now, I haven't gotten to the end, but he presents compelling evidence that every time there was an advance in electromagnetic communication, a pandemic followed right away within 1 year, and then gradually it disappeared. And that he gives an example of 3 or 4 different examples and other evidence for the role of electricity. Now, some electricity apparently is beneficial if it's got the right frequency and such. There are people who are using various electromagnetic sources to improve blood flow and other applications. But I think one needs to be cautious, and what's really necessary is an open discussion of the evidence. And there are some interest groups that don't want open discussion because they profit.
That's the key word, open. Right?
Open. It must be open. Yeah. And I would hope that happens. Our environment is getting crippled by, as people know, it's not only the electromagnetic background and electromagnetic waves, but also the pollution that exists, and et cetera, et cetera. So, we need to do something about that, obviously.
Yeah, great.
Yeah, and I'm, hopeful that something. So out of this, I should mention, we're trying. We had a startup company, still have it, but lacking something in investment and such, to solve some of these problems. And one of them is a filter. It's called a filterless filter, and it works by extracting EZ water because EZ water excludes all the junk. That's why we call it exclusion zone, because as it forms, it pushes out all the junk. Just like when ice forms, if it's a pure crystal, the water, which may have contained junk in it, is pushing out the junk to get a pure crystal. And this is more or less the same. And so we working in our laboratory, it works very well, but what's necessary for practical use is to cross over the so-called valley of death, from the laboratory to something that's practical. And we've been working on this, and also working on getting energy from water and sunlight, another application that has come from the research. And I mentioned to you that the easy water typically is negative charge, and the ordinary water beyond is positive charge, is a battery. So we've demonstrated that if you stick two electrodes in, one in the positive, one in the negative, you can light a light bulb. That needs to be developed as well, and we're excited about those developments. So at any rate, it's not just theoretical what we found. It's not just health and filling your cells with water that we found, or filling your cells with easy water, but it's also all around us in nature and technology that these principles, which I believe are mostly correct, and people have taken them up, people who are outside of the field of the so-called chemistry of water, who understand that water is really important for almost everything. I think this is the beginning of I don't know, some kind of revolution that's happening.
Oh, I think so, for sure.
It's really exciting to be there.
Well, you're a pioneer, Doc, and your book is revolutionary. And I jumped on your site, which I love. And when you go under your site, and there's a section that says Jerry, where you can click on that, and I've got it on my phone that I'm showing you right here. It's one of my favorite quotes, and I'm gonna do it now. The overriding philosophy of the laboratory is that science is essentially simple, and I like that. No.
Well, I like it too, and many people have thought so for many years, but in the past century or so, it's changed. And my colleagues, my fellow scientists, revel in standing up at the podium and saying, or implying, "Hey, look how complex my subject is, or what I'm dealing with." There's a sense that, hey, if it looks complicated, it means I, as the presenter, must be smart, and I'd like to present myself as smart. But I think Mother Nature was the smartest of all, and I'm convinced, not everybody is, that Occam's razor applies, that if you have two theories, the simpler one is likely to be the one that's correct. And that has been my philosophy for some time. It's the lab's philosophy as well.
Well, I'm in your camp, Doc. I'm right there with you.
Well, I guess we're together, and I'm glad of that. And so anyway, it's been a pleasure, and thank you for the opportunity. I'm excited about the future of science. And let me just, since my guest is not quite here, if I can take 2 minutes to mention the Institute for Venture Science. What's that? So we developed an institute to promote ideas that are promising, but ideas that challenge conventional scientific thinking. Okay, why that? The reason is it's really difficult for an unconventional idea to get traction. Most unconventional ideas are rejected. Even Einstein was rejected, and of course Galileo, but there are many current day scientists that understand that if you have an idea that runs against the mainstream, forget it, you have no chance. And by chance, I mean, in order to get traction with your idea, you need to get evidence. And to get evidence, you need scientific studies. And to do scientific studies, you need money. Well, nowadays, the money comes from government agencies like the National Institutes of Health, the National Science Foundation, and it doesn't work in your favor. And the reason it doesn't work is this, just to give an example that I like. Suppose everyone in your environment thinks the Earth is flat. Okay, and you come up with an idea that, maybe the Earth is not flat, maybe it's a sphere. And you even have preliminary evidence because you've looked at some videos taken by spacecraft and it looks round. And you've also gone around the world and you're looking for the edge of that flat Earth. And you looked assiduously, but you had great difficulty detecting any edge. And so you come to the conclusion that, you know, it might be that the Earth is really not flat. It might be round. And you think, this is so important. I really want to study this. So you go to the National Science Foundation or whatever, and you put in a grant application. Please give me some money so I can study this because, you know, potentially it's pretty important. Do you think you're going to get your money? No, you won't get your money. Why not? The reason is this. The reason, there may be other reasons, but one reason is that the people who run the foundation try to recruit the most accomplished experts that are available. And your project application looks pretty important. So if I'm the gatekeeper there, I'm going to try to recruit the most distinguished scientists who know something about the shape of the Earth. And I'm recruiting them to say, you know, has Perry got an idea that is significant, important, or is this just bullshit? So your application goes to those reviewers. And what do you think those reviewers are going to think? They're challenged. If you're right, they're wrong. If they're wrong, they lose their supremacy. They lose in scientific society. And, you know, we're all human. We don't like that. Even I or you would like that. So the system is set up in such a way as to almost guarantee that if you challenge the establishment, you won't get anywhere. So I had the idea of doing something about this, and we've developed this institute, where it's to the point where we have a 501c3 that's you know, a charity organization. We've gone through a vetting process of dealing with more than 200 pre-proposals. From that, we've gone through various stages of review, as extensive as any organization, and probably more so. We've picked 5 projects that we'd like to fund. We're looking for money, and that money is not going to come from any government. It'll come from private sources. So we're just now beginning to let people know of our existence. And, you know, if anybody has interest in doing something really meaningful for science and therefore for humanity, please contact me. We would like to talk with you.
Yeah,
So,
is there do you have a dedicated website for that, Doc? Or is
we
it
do,
everything?
yeah, IV as in intravenous, ivscience.org, ivscience.org. It's
Okay,
kind of
I
a nice
will
website.
actually post the link here for everybody that's listening.
Oh, that's
so
great. Thank
You
you.
can go to that. And I'll have also your link to your pollacklab.org.
Oh, thank you.
So they can go to that too.
And
Doc,
you
thank
might,
you so much for coming on and taking the time with me today. I'm sad it had to end, but I really did enjoy it immensely. Thank you.
thank you very much. My pleasure. Take
All right,
care.
you take care.
Bye.